Looking at the Thursday afternoon into the evening threat, I'm not liking exactly what I'm seeing in the southern portion of this threat into Illinois. However, I am starting to have some concern in eastern Wisconsin, as well as when the storms move further out east into western Ohio. Comparing both the GFS and the Euro model, GFS is still consistently faster in development than the Euro. So the GFS displayed is a little bit further east with the closed low up a little further north, and the Euro is a bit farther south of the closed low and a bit slower. So what this tells me is if the GFS is able to verify, then we could have the surface front pretty much cutting through all that unstable air and making it stable at the low levels. And that would help inhibit the supercell development parameters needed for a widespread severe weather threat. But if the Euro is able to play out, then we could have a more uh, significant threat with this setup, just because it's a slower system and slower systems are usually stronger because they have more time to develop. Now, looking at the low level jet with the GFS, it's still relatively weak, as well as having a southwesterly flow in Illinois. And so that's something that I'm really keeping an eye on because it could really help with suffocating those storms. They need to have that rich moisture that requires a southerly wind flow from the source region of in the Gulf. Looking at the Euro, though, it does have that southerly wind flow and having that rich moisture needed, as the source region is from farther south. Now, digging into the 500 millibar height with relative vorticity added with it, just some background on what this shows and why it's important. Um, so, all of this purple right here, that is all an indicator of having really strong cyclonic spin, and that's going to help with um, making those air parcels in the atmosphere move upward faster and have more instability. Um, but that's not what I'm looking at right here. I'm looking at this low, the vorticity low right here. Um, Everyone's gonna like this is what catches everyone's eye. That's not necessarily what we need to be looking at as a meteorologist. We need to be looking at all the more subtle farther out eastward vorticity lobes. So this column right here, that is an indicator of if storms are able to develop, then having that vorticity at the mid levels will help accelerate those air parcels upward, generating some more upward vertical motion and increase the exhaust in the upper levels needed for having long-lived supercells. The Euro model is showing something similar too, with having this lobe in the general vicinity as the GFS. But looking into Wisconsin as well, it's having that vorticity lobe. Um, and that's another area that I'm starting to get a little more concerned with having some sort of severe weather threat, whether that be hail, a squall line, um, or anything else really. With the synoptic background environment out of the way, you're going to start looking into the thermodynamics needed for having this severe weather threat to play out. So looking at the mixed layer CAPE, I'm going to be looking at the Euro model, the NAM, and the NAM 3 kilometer. NAM, it's pretty consistent. It has been over the past few model runs with having this really large area of high CAPE. The NAM, as mentioned in my previous video, the NAM is uh, pretty consistent in having an over forecast of CAPE values, as well as the NAM 3 kilometer too. That's the convective allowing model of the NAM. So what I'd like to look at these two here for though is what can happen if the cap is able to break. So I'm going to show you the Euro model in this central Illinois, show you what that looks like. It has this cap right here. Uh, Although it's small, it's still there, and that's going to be one of the indicators I'm looking at across all uh, global and convective models for the potential for having a tornado setup. Looking at the NAM, it is the same exact time, same exact spot as the Euro model. you can see that the cap is broken here. This dotted line is the path that the air parcel takes, and so it's going to be traveling outside of that warm nose right here, and that's what would be contributing to the cap. As well, you can see the convective inhibition. That is the fancy term for cap. It is zero across the board at the surface, mixed layer, no forecasted cap, and the most unstable cap is not there either. So that's what I mean when the NAM has a tendency to have an over forecast in the severe weather parameters. So now looking at the NAM 3 kilometer, still having the same time, same location, same everything, Central Illinois. The cap is there. It's very weak. It would be very easy for any air parcel to make it through this air column and break through and have some convective development just because of how weak the capping is. Um, what I'm looking at with the 3 kilometer though is the lapse rates. It's 8.8 degrees Celsius per kilometer at the mid levels. On the NAM, it was 8.4. Although that is pretty subtle increase, it's once you get to those high numbers, uh, any sort of increase becomes more and more magnified. So if storms were able to have this type of environment, then we could have a more significant severe weather type setup. Now looking at the surface-based cape from the GFS, as you can see, the GFS, it is also having a faster progression with the surface-based cape. Unfortunately, Pivotal doesn't have mixed layer cape with GFS, so that's why I'm having to go back and forth. So here is the surface-based with the GFS, and then here is the mixed layer cape with the Euro. As you can see, the higher cape values are farther west compared to the GFS, or yes, compared to the GFS, and so that is another thing I'm going to be keeping an eye on too. If you take a look at the service-based cape over Wisconsin, that is something that is concerning to me. Um, it wasn't having that high of a signal on the previous model runs, but now that we're getting closer and closer to this setup, it's something that I'm going to be looking at a little further into. The lapse rates are also relatively high. They could be higher, but anything pretty much above 7, that's my personal threshold of what I like to look at for having a volatile type setup. Now looking at the bulk shear, the GFS and Euro model are pretty consistent in having the strength of shear needed for supercells to develop, which, if you remember from my previous videos, I mentioned that all you need is 35 knots of bulk shear. GFS has it 35 knots as the peak in southern Illinois. The Euro model has it a bit more widespread across Wisconsin into southern Indiana, and the NAM is more centralized in central Illinois. The NAM 3 kilometer is also pretty centralized, just a little bit further east with the max wind shear 70 knots. So now with all of those factors in mind, I'm going to be looking at the supercell composite. Unfortunately, the Euro doesn't have it on pivotal weather. But so we're going to continue looking at GFS, NAM, and NAM 3 kilometer. Um, the GFS is a bit further east into Indiana, as expected, with having a faster progression of that low. The NAM is a little bit further west and more intense in east central Illinois, and the NAM is a bit more. The NAM 3 kilometer is a bit more in line with the GFS. If the Euro model had a supercell composite, then I would say that it's shifted a bit further west and probably a little bit of a higher indicator than the GFS, just because it is a slower moving system compared to the GFS. And so that means that the atmosphere has more time to destabilize. Now, zooming in a bit more into the Midwest, I'm going to show you just how important having that moisture is for the potential for having the supercells develop. So GFS has absolutely nothing in the part that I'm focusing on in Illinois. The NAM has a bit more. It's more widespread and just looks like it could be like rain showers or something like that. However, the NAM 3 kilometer, the one that had the most moisture return, is where we're seeing a lot more of those potential discrete supercells developing across the entire state. So if the moisture is able to develop like the 3 kilometer is showing, as well as have the cap breaking, then we could see something more like this across central Wisconsin into southern Illinois and moving farther east into western Ohio throughout the night.